Hello everyone, welcome back to this channel. So let's continue our course Intro to Machine Learning. As of now, we have understood how models work, how to explore the basic data, right? Then we did machine learning model. We understood model validation, underfitting and overfitting. Let me give you a small recap. Uh, by coding, we can understand what are the things we have done till now. Imported pandas. Then we have read the file path. We have converted the file into a data frame. After that, we have decided the output feature. These are the input features. Then we splitted the data into two parts, validation part, training part, so that you can do the training on training part and you can check the accuracy on the validation part, right? We used decision tree model, which is a simple model. You can use any model later on. Then we trained the model by using the fit function. After we have trained the model, we are predicting on the validation part. Okay, the data set was divided into two parts: training part, validation part. So training part is used for training, and now the validation part will be used for validation. Okay, and once you have done this, you will check the mean absolute error, so you can understand what how your model is actually performing. So all these things we did, and after that we also understood how to take different types of leaf nodes so that you can overcome overfitting or underfitting, right? Because overfitting will be a problem and underfitting is also a problem. So we have to take a midway between these two things, right? Now today our course is random forest. First we will read and then we will do the exercise. Okay. So decision trees leave you with a difficult decision. A deep tree with lots of leaves will overfit because each prediction is coming from historical data from only the few houses at its leaf. As I said, if you split the tree into many parts, then what will happen? Every leaf will contain a very few houses because there are so many leaves. So every leaf will get a few houses. So the problem will be that when you give a new data set, it will perform very poor. Similarly, if you use a shallow tree, a very small tree, like very few splits, so what will happen? It will perform poor because it fails to capture as many as many distinctions in the raw data. So if you take too deep, that will cause overfitting. If you take too shallow, then you are not actually splitting at all. So what is happening? Every leaf has so many houses. So that is also a problem, underfitting problem. Okay. So now even today's most sophisticated modeling techniques face this tension because between underfitting and overfitting. But many models have clever ideas that can lead to better performance. Okay, so that is random forest. We will study that today. Okay. The random forest uses many trees and it makes a prediction by averaging the predictions of each component tree. It generally has much better predictive accuracy than a single decision tree and works well with default parameters. So it is like when you are using many trees, not a single tree. So that will always give you a better performance because if you take a suggestion from many people rather than taking it from one people, that will always be better. Okay, so same here. You are taking many trees rather than taking one tree. If you keep modeling, you can learn more models with even better performance. Okay. See, you have already seen these things. Training, validation, training output, validation output. See, this is the data set converted into a data frame and the values which are missing are simply dropped. This is the output. This is the input and you are doing the trend test split. So data set is divided into two parts. Now what you are doing, you are importing random forest regressor instead of decision tree regressor. So random forest will contain many decision trees. Simple. Now mean absolute error. So random forest regressor and you are training the model. Now you are predicting the model and this is the checking of accuracy. Okay. So this is the absolute error. So what you have to do, you have to minimize that error. If you minimize this error, your accuracy will be improved. So there is likely room for further improvement. Yes, because you can see it's a huge error. But this is a big improvement over the base decision tree error. Previously, this was the error. So we can say it's better. So taking a random forest, taking decisions from multiple decision trees is better than taking a decision from a single decision tree. Right? Now there are parameters which allow you to change the performance of the random forest. Every algorithm you use have many parameters. Like in decision tree, we saw that we can change the number of leaves. So similarly, random forest also has different kind of parameters which we are going to learn later. There you can tune it, you can just increase something, you can decrease something, and then you can calculate the errors. That's what they have said, that you can improve, you have chances to improve. Okay, but one of the best features, as we change the maximum depth of the single decision tree, as I said right now, but one of the best features of random forest models is that they generally work reasonably even without this tuning. Now let's do the exercise. Random tree is nothing but a collection of decision trees so that performance can be improved because you are taking suggestions from multiple people. Now let's do a recap. First, let me run this. See, pandas imported, all these things imported because these are going to be used in the model. Now this is the file path, .csv file. You have converted it into a data frame. You have you are going to calculate the sale price. So this is the output. These are the input features, lot area, bathroom, first floor, all these things. Now you have divided the dataset into two part, training part, validation part. Okay, you are importing decision tree regressor. So you are creating an object of this class. Now you are training the model by using the fit function. Training on what? On train X and train Y. This is the input. Input used for training, output used for training. Okay. Once you have trained, now you are predicting. Predicting on what? On this validation part. This is not used for training. Okay. And then you are taking that output, the val predictions output, which is the prediction, and this is the real output, validation y, right? So you are comparing them so that you can calculate the mean absolute error. Perfect. Later on, you have just tried to check which one will give you the best solution, like which max leaf nodes that we did in our last class. 100 was performing better, so they have just tuned it so that you can solve the problem of overfitting or underfitting. Okay, and your performance is improved. So you are taking 100 and the same things you are doing, you are training, you are predicting, you are calculating the mean absolute error. Clear? So before tuning it was 29, now it is 27. So you can clearly see that it is improved. Okay, so using max leaf nodes parameter has helped you to improve your model's accuracy. Now let's do the exercise. So use a random forest model. Okay, so you have to write random forest regressor and the random state equals to 1. Okay, now you can fit the model. So just copy it, dot fit, and here, sorry, I didn't copy this properly. Okay, you have to train it. Okay, so you can write train x, train underscore y. Okay, now you have to calculate the mean absolute error. So first you have to do the predictions. So how can you do the predictions? You have to write rf prediction equals to, take this one, dot predict function will be used on val underscore x. Perfect. So once you have done this, you can write mean absolute error, and this is our predicted value from random forest. And what is the real value? Well, y. So once you have done, you just can run this. Okay. See, it was before 27 in decision tree. Now it is 21. So it has improved a lot. Okay. Now you can also try different other algorithms also. But here they have simply understood you, simply explained about decision tree model. And random forest is related to that, just attaching multiple decision trees. It's like taking suggestions from many people rather than taking from one people. The same concept here also. Random forest is not a different algorithm, but taking decisions from multiple decision trees. So that's why it is performing much better. Okay, so we have completed our course, and now you can participate in this machine learning competitions. So here, see, this is housing prices competition for Kaggle Learn users. You can do this in the next exercise. Create a submission. Let me see what's there. This is the introduction. Run the setup. Same. They used a random forest regressor. All the things we have learned. Let me first run this. Now, train a model for the competition. To improve accuracy, create a new random forest model which you will train on all the training data. Oh, okay. Okay, fine. So, on full data equals to, let me copy. Random forest regressor, random state 1. Now, on this dot fit x comma y, because here you are doing this on all the data from the training set. Okay, so we can write x comma y. Fine. Now read the test file. This is the test file that is in CSV format. Here you are not using the validation file, but you are using the test file to check how your model is performing. Okay, fine. Now you have to read the test data. Okay, so you can say the code pt.read CSV. You are converting the CSV file to data frame. Simple. Copy this, paste. Okay. Now the list of columns is stored in a variable called features. So okay, test data features. Okay. Make predictions. So mm, copy. Then which function? Predict and on test, because you are have not used validation here. So oh sorry, test training. X is the training, Y is the output. Okay. Now check solution. Now to generate a submission, they have written the code that the output will be converted into a data frame. ID is the input, sell price is the output. So you are converting the file to CSV file. Okay, that's it. Now you can submit it to the competition if you want. Learn more, then try to participate in Kaggle Learn competition. Okay, so we have finished our Intro to Machine Learning course. Congratulations. Meet in our next class. Till then, bye. Happy learning.